Probability is simply the likelihood that an event will occur. It is the chance of an occurrence. Probability is a daily experience. We can itemize probabilistic events. The chance that it will rain, the chance that an individual contract COVID or transmit, the chance that it will be a boy or a girl. All this is a matter of probability. So probability is applicable on a daily basis. And we are going to look at what is called conditional probability. Start with probability must range between 0 and 1. You can never get a negative or more than 100% or 1. So this gives you what we call the sample space. So probability, if your answer is 1.2, just know there's something wrong somewhere. Then we have the union set. Probability of A union B to unite is to add. So probability of A union B is when you add probability of A, and when you add probability of B, you subtract what is in the middle here because it's intersecting. This is called the intersection set. A intersection B. So if you're taking quantitative methods together and 3 other courses, so the total you're taking is 3 plus 3 minus the 1 year sharing. So this is what we call the union set formula. If you're going to the conditional probability, A given B, you take the B down there, then intersect A intersection B, or B intersection B. Either way is okay, because you're multiplying. To intersect is to multiply. So A given B is A intersection B divided by the probability of B. This one goes down there. Such as when you cross multiply, A given B times probability of B will give you the intersection. As long as the base is the one that you're multiplying again, you get an intersection. Similarly, if you're given B given A, the A will go down there and you're going to have A intersection B. So this gives us another intersection set formula if our conditional probability starts with B given A. So here we have B given A times A. So notice the pattern that whenever the bottom or the denominator is what you're multiplying the conditional probability, you automatically get an intersection. So B given A times A will give you the intersection of what? B and A. So here A given B will multiply by B. B given A will multiply it by what? A to get the intersection. Then we have the complement. A complement plus A should give us 1. So if A is 0.4, meaning the complement of A is what? 0.6. The remainder to get 100%. If A is 0.1, the complement should be 0.9 or 90%. So the complement is simply the remainder to get 100 or 1. So it also follows that probability of B plus the complement should also be 1. So my question is, if our B is 0.2, what is the complement of B? If our B is 0.2, what is the complement of B? Yes, Tandy?
0.8.
0.8, exactly. So with this being mentioned, we're now going to look at how questions come. So you'll be given the probability of A as 0.1, probability of B as 0.2, and probability of A given B as 0.3, for instance. Then you're asked to find, number 1, the intersection. So the intersection of A and B I said you can do it in two ways. Number one, you can do it directly by just finding the conditional probability, which is A given B, and to get the intersection, you multiply by the base. So A given B times B itself. Because once these two are the same, you get an intersection. So A given B is 0.3. Probability of B is 0.2. You multiply these two, you get 0.06. Just make sure that this letter must be the same as this letter here. But if you forget, you always start from the conditional probability, you expand it. So we're going to have A given B will be expanded as follows. What goes down is the probability of B first, so that you don't make a mistake. Then on top, we're going to have what? A intersection B. Then you replace where there is A given B, put 0.3. Where there is a intersection, we don't know. Just put the intersection. Then probability of B, we have 0.2. So you cross multiply. 1 times the intersection is the intersection of A and B. Then you cross multiply 0.2 times 0.3, give you what? 0.06. Is that clear? Then we go to the union set. This one is the most faithful formula. A union B, we said is to add, is to unite. So probability of A plus probability of B minus the intersection of A and B. So probability of A is 0.1. Probability of B is 0.2. And the intersection is what we just calculated, which is 0.06. So when you add this, we get 0.24. So this is dependent on the answer we just got here. So if this is wrong, the union set is wrong too. So what is the complement of A and what is the complement of B? Complement of A is 1 minus A itself. So if our A was 0.1, the complement becomes 0.9. If our B was 0.2, then our complement will be 0.8. So the complement is a difference between 1 and that probability itself. So that is how we find the complement. Now, suppose you're asked to find the opposite probability of B given A. Can somebody expand this for me? What's the probability of B given A? A intersection B. We usually start with the letter which comes first in the alphabet. You can even put B intersection A, it's also the same. But what comes down here is the A. So we already found the intersection as 0.06. And our A is 0.1. So when you divide this, you're going to get 0.6. Okay, so now I want you to try. Suppose we're given probability of A at 0.4, probability of B at 0.3, and probability of A given B as 0.4. I want you to find part 1, the intersection of A and B. Part 2, find the union set of A and B. Part 3, find the complement of A, the complement of B, and part 4, find probability of B given A. In part 5, to comment whether they are what? Mutually exclusive or independent. So in that order, I'll give you 5 minutes. You try. Are they mutually exclusive or they're independent? So try. I'll give you 5 minutes to work that out. So these are the solutions that we're supposed to get. The intersection, ensure you look up the conditional probability, particularly the base. A given B must multiply by the B itself. So we multiply A given B times B, 0.4 times 0.3, we get 0.12. Now this is part of the formula of the union set. A union B is A plus B minus the intersection. If you're not given this, and you're asked to find the intersection is to multiply, you would have simply multiplied these ones directly. 0.4 times 0.3. Coincidentally, you're finding the same answer, 0.12. Not that it should always be the same. So A union B is A plus B minus the intersection. So this answer here, if it's wrong, it will affect your answer down here. So A was 0.4, B is 0.3, you subtract 0.12, you get 0.58. The complement of A and B is 1 minus the probability of that particular event itself. So A complement is 1 minus A itself. So 1 minus 0.4 is 0.6. Then 1 minus 0.3 is 0.7. So this is how we find a complement. Then B given A, we pick our A here, and intersection of B intersection A or A intersection B, either way. So our A was 0.4 and our B and A intersection was 0.12. When you intersect them, you get 0.3. To know whether they are mutually exclusive, to be mutually exclusive is to have nothing in common, is to have 0 as intersection or empty set. So A and B was 0.12 rather than 0. So we can say these are not mutually exclusive events. But in this case, A given B must go to A. To be independent is to be unaffected by any other event. So A given R must still be A. A given A must still be A. So A given B should be A. Our A given B was 0.4 and our A was 0.4, which is the same. Suppose I wanted to use B given A. Yes, B given A must be equal to what? B. The top guy must be maintained. So our B given A, we found 0.3. And what is our B? This was 0.3. So you see that you're still getting the same answer. So this is the correct answer, regardless of whatever you're going to use. Also this, you're getting the same figure. Is that clear?
Yes, it is.
So lastly, sometimes you'll be asked to use the same conditions for contingency table. A, B, X, and Y. We have 2, 3, 4, 1. The total here is what? 6. The total here is what? 4. The total of totals here is 10. The total here is 5. And here it's 5. for what is the probability of A? It's a total for A over the grand total. So A, it's 5 out of what? 10, which is 0.5. About B, we go to the total for B, which is 6 out of what? 10, which is 0. What? 0.6. About X, the total for X is what? 5 out of 10, which is 0.5. And the probability of Y is the total, which is 4 out of 10, which is 0.4. Then the intersection of A and B. You go where they meet, A and B, you draw a plus. A and B, they meet at what? 2 out of the grand total, which is 10, which is 0.2. And X and Y, what is the intersection of X and Y? Where they meet, where do they meet? You draw a plus. X and Y, they meet at 1. So 1 out of 10, which is 0.1. But when you're looking at A given B, you still go where they meet. A and B, they meet at 2. But the total for the bottom letter, B, the total is 6. We're going to have 2 over 6, which is 0.33. Suppose we swapped it. We had B given A. They still meet at 2, but this time the total for A is total. What is A? Total for A is 5. So 2 out of 5, we get 0.4. What is X given Y? Where they meet, X and Y, they meet at what? 1. But the total for Y is 4. So 1 over 4 is 0.25. Then Y given X, they still meet at 1. But this time the total for X, which is 5. So this will give you 0.2. But the union set for A and B is probability of A plus probability of B minus the intersection of A intersection B. This is A union B. So our A we found as what? 0.5. And our B 0.6. And our intersection 0.2. Which gives us 0.9. Now help me, how do we find X union Y? What is X union Y? What's the formula for X union Y?
Probability of X plus probability of Y minus probability of X union intersect Y.
Probability of X plus Y
Probability of Y
minus
X intersect Y.
what is our X?
0.5
Y
plus 0.5
intersection
That's 0.1.
minus
0.1.
what's the final answer?
0.1.
What's the final answer?
1.
0.9,
1.
0.8. Okay,
1. Oh, 0.8.
so this is where we end. I will send you homework based on this. Are there, unless there are any questions? Are there any questions?